Hi, everybody. Welcome to week 2 of virtual learning. Welcome to science class awesomeness. I hope you guys had an awesome weekend. I wish I could hear about it, but that's okay. But I hope you're ready for another good week. And then we got spring break, which is right around the corner. How awesome is that? But what we're going to be talking about today is waves, and we're going to be talking about the frequency and the wavelength and the energy of waves. Okay, now I'm going to show you some calculations, and we'll go from there. Okay, so waves, let's see if I can do this. Waves act like a wave, and they travel at the speed of light. Okay, so light travels at 3.0, so 3 times 10 to the 8th power meters per second, or 300 million meters per second. That's insane. That is so fast. That's crazy. Okay, so that's how fast light travels. Now, a wavelength, all right, so hopefully this is review, okay? We have a crest, we have the trough. This is the wavelength here from crest to crest, okay? Those are all wavelengths, okay? Hopefully that's a review from last week. All right, now frequency. If I decrease the wavelength, I increase the frequency, okay? Now this is the equation right here, all right? C is equal to the speed of light. That is always gonna be 3 times 10 to the 8th. So that's C. All right, this little giraffe looking thing, that is gonna be our wavelength. Okay, that's known as lambda. That's our wavelength. And this little V looking thing, that's gonna be our frequency. I will write it out here in a minute. Okay. There they all are. Okay. Yep. Okay. So if you need to pause the video to take a minute and write this down, okay? However, now I'm going to show you guys a practice problem of how to solve it and the different steps to solve the problem. Okay, so here we are. Here's a sample problem. So it says light with a wavelength of 650 times 10 to the negative 9th meters appears red to us. Calculate frequency. Okay, so I know my equation is C is equal to lambda times frequency. All right, so step 1 is done. Write my formula. Fill in the knowns. Well, I know that the wavelength, this is my wavelength, is 650 times 10 to the negative 9th. So I'm going to write that. 650 times 10 to the negative 9th. All right, I'm calculating my frequency, so I don't know that. However, do I know what C is, the speed of light? Yes, I do. That will always, always, always be 3 times 10 to the 8th power. 3 times 10 to the 8th power. Okay, next step. I need to isolate my known. Isolate my known. So excuse me, getting choked up here. All right, here we are. So I need to get my frequency by itself. So the opposite of multiplication is division. So I have to divide 650 times 10 to the negative 9th to the other side. Okay, so what this is going to look like is my frequency is equal to 3 times 10 to the 8th over 650 times 10 to the negative 9th. Okay, now when you're plugging this in a calculator, it will be very helpful to add parentheses. I actually very much recommend it. Okay, so I'm going to plug it in my calculator real quick. So I have 3 times 10 to the 8th power divided by 650 times 10 to the negative 9th power. And I got yowzas. We can round to the nearest hundredth place. Okay, so I got 4.61 times 10 to the 14th power. Okay, so wavelength is measured in meters. Frequency actually is measured in hertz. Okay, it's measured in hertz. That's our unit. So that's how you solve a problem like this. 4 steps. Write the formula, fill in knowns, isolate the unknown, solve. Okay, so there's one type of problem. Okay. All right. So let's go back. All right. Now, the photoelectric effect. So, the photoelectric effect. All right. The definition is the emission of electrons from a metal when light shines on it. So when light shines on this metal, pow, 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 the electrons actually bounce off of it because it causes energy. Light is energy, okay? And this is how the wave theory couldn't be explained without this. Okay, so there was this guy who, some genius, some Max Planck, oh man, I wish I was him. But he studied how light emitted. And then he developed the quantum theory of quantum. So the minimum quantity of energy that can be lost or gained by an atom. And he proposed a formula, all right? E is energy. H is Planck's constant, all right? We call it Planck's constant because, well, he kind of came up with the idea. Okay, so this huge number, 6.626 times 10 to the negative 34 joule seconds, that is going to be H. That will always, always, always be H. Every single problem, that's going to be your H value. All right, and once again, wait a minute. That's frequency. That was in our other equation. How cool is that? It's in 2 different equations. Okay, so I'm going to describe how to solve a problem using this. Okay, let's see if we can come back. Stop share. There we are. Okay, so sample problem number 2. Same exact 4 steps. How awesome is that? Okay, so let's read the question. What is the energy of a photon of light with a frequency of 4.62 times 10 to the 14th hertz? Well, if it says what is the energy, I know I have to use the energy equation. So energy is equal to H times my frequency. Fill in the knowns. Well, I don't know my energy, but I do know H. H is always Planck's constant. 6.626 times 10 to the negative 34th times my frequency, which is in the problem right here, which is 4.62 times 10 to the 14th. Isolate the unknown. Well, I already did. E is my unknown, and it's already isolated, so I can just skip that step. My last step is solve. Now, once again, I very highly recommend using parentheses when you plug it into your calculator, or else you're going to get some weird number. So 6.626 times 10 to the negative 34th power, parenthesis, times, parenthesis, 4.62 times 10 to the 14th, parenthesis. And I got something around 3.06 times 10 to the negative 19th. Now, energy. We all hopefully know what energy is. Energy is measured in joules. And that's how you solve a problem like that. Okay? So, well, I hope this helps you solve the problems for the day. I have a pretty cool activity, hopefully, for you guys on Thursday. If you have the ability to get a Hershey bar, that would be very helpful for the activity. If not, I do have a secondary activity. But guys, I hope you have an awesome week. Awesome, because you guys are awesome. I hope you guys are hanging in there, staying strong. I hope we get to see you guys sometime soon. All right. If you have any questions, please shoot me an email or join my Zoom. All right. We will talk to you later.